All right, in this video, we are going to be on page 1 of notes 12 of Calc C, and we're going to answer a question that I've always thought should be a more common question, but isn't. But then again, I don't really teach like the beginning of graphing functions, so maybe it is a more common question than I realize, and people just forget it by the time they get to me. We're going to talk about the arc length of a function. So arc length is exactly what it sounds like. It's how long a function is, right? Have you ever thought about y equals x squared? Like, how long is that function between x equals 0 and x equals 1? And why don't people wonder about that? I don't really know, but we're going to try to answer that. So we're essentially saying, like, if the curve was a path that something was crawling along, say an ant or a bug, like how far does the bug crawl if it crawls from one point to another point? That's what we want to try to answer. So let's see if we can work out where this comes from. So we have this function. It has it's a little weird, and it's a little weird so that it will go through a bunch of lattice points, because I didn't just want to use y equals x squared, but I also didn't want it to be like crazy annoying. So this is our function. And what we're going to do is we're just going to make a bunch of line segments and then add those up and say that that probably approximates the distance. So what we're essentially doing is we're going to find from here to here, then from here to here. And you can see I'm drawing line segments, and they're doing a really good job, I think, of approximating that arc length. Now the arc length, you can tell, is a little bit longer than what we're going to get, but a good approximation. So what we're first just going to do is find the distances, right? So use a little s. So I'm going to say S1 is for the first arc length that we're finding. So that's going to be this. This is S1, S2, and S3. So find little arc lengths, and it's just a distance formula. So 2 squared plus 1 squared, so radical 5, and then S2 square root of 2 squared plus 2 squared, so radical 8, and then S3 is going to be the square root of 2 squared plus 3 squared. That's a plus sign. That's equals 9, and so radical 13. Okay, so now what we want to do is add those up, right? And say that that's the approximate length. So that'd be the square root of 5. So S, the total length, is approximately square root of 5 plus the square root of 8 plus the square root of 30. I really don't know why they use S. Usually the answer to that is Euler. And so usually the answer is like something in German, or what did he speak? I don't know, probably German. Swiss German mathematician? I don't know what he was. So we get this. That's our approximation. But then, as with everything in calculus, how do you get a better approximation? Use more divisions. Use more division. Partitions, let's say, instead of divisions. Partitions. Partitions. Okay. So if we use like 20, we would get a better approximation. If we use 1,000, we'd get an even better. In general, we'd like to use like an infinite number, right? So let's see if we can work out what's happening. So in each of these cases, we had a delta x and a delta y. Like this, we'll use different colors. This is like delta x1, and this is delta y1. And then we had, so with most of these sorts of things, usually your delta x's stay consistent and your delta y's actually like vary. Delta y, 2, and then here. And so that is the case here as well. That's what we're doing. Basically, we can choose delta x because we know where x starts and where it stops. So we'll just be like, we want to cut that into 50. So delta x is b minus a over 50. Delta y, on the other hand, is dependent upon, these are 3's, is dependent upon the x value, because we're going to plug into the function. So we get this. So essentially what we're doing there is delta x squared plus delta y squared square rooted. Delta x squared plus delta y squared square rooted. So now we're just going to kind of do that in general. So here, what we're saying is we want to add up from I equals 1 to n, auto shape, 1 to n, the square root of delta x sub I squared plus delta y sub I squared. And so then what we can do is we can mess around with this. So we're going to do that in a particular way. So what I'm going to do is I'm going to take delta x sub I squared out of everything. So that'll leave me 1 plus, and then the weird thing here is we get delta yi over delta xi squared. And that we can say is I'm going to take out 1 plus delta yi over delta xi squared. Okay, we're taking out, taking this out, right? Square root of that. Technically the absolute value, but like we're just going to choose it so it's positive. So we'll just say delta x sub I. Okay. Now all the delta x's are the same. So like the fact that we're using sub I is like, that's nice of us, but we don't really need to. Now, if we take the limit as n approaches infinity, so if n approaches infinity, this means that delta x sub I approaches 0, right? Because we're dividing like a fixed amount by infinity now, so like it's gone to 0. This thing, square root 1 plus. So this is really a Riemann sum type thing. Delta x becomes the integral from, let's say a to b of the square root of 1 plus, well, if delta x goes to 0, delta y over delta x goes to dy dx squared, and then our delta x becomes dx, and then let's just notate that that's your x start, and this is your x end. And there you go. So I don't know why I decided to put an exclamation point there. That's it. So this is the derivation of how we can find arc length. So what we could have done, so now what we could have done is we could have found dy dx, squared it, added 1, put a radical over it, and then tried to integrate from a to b. What happens usually, unless the problems are chosen like really, really specifically, this integral is very challenging. So most of these are like set up but do not evaluate, or set up and then use your calculator or whatever. But it's all based on the Pythagorean theorem. So like if you forget it, you can actually work this out again. Like this is not one of those impossible to work out formulas. And just remember these are the x start and stop, and it's pretty straightforward. So I'll be back in the next video and we will, I don't know, probably do some problems because that seems like the logical thing to do. So I will see you there.